Yes, students, good afternoon to all. Why we gathered here now? It's a last minute preparation, right? So we are giving really important areas of each and every chapter. You should do revision again. So here we won't explain the topic, just we will give the important topic which you have to revise in the last minute again. Okay, so we are doing one by one chapter which is required for the board exam. These topics are prepared by checking past year papers and this will be very useful for you. So we are starting the session. Okay, hope all of you can hear me. Yes, so we are starting now. First chapter you have solutions. Solution chapter has a weightage of 7 marks. Out of 70, 10% of mark is coming from solution. So it has a weightage of 7 marks. So which are the area in it? There is actually, it's a numerical chapter. Out of 7 marks, you can expect normally 5 marks numerical or 4 marks numerical altogether. 2 plus 2 or 3 plus 2, like that. And definitely there will be 3 marks or 2 marks theory part. So which are the area you have to concentrate here? So number 1, there will be objective questions based on molarity, mole fraction, mass percentage, like that. You have to study the equation of each and everything and go through the objective part, numericals based on molarity, mole fraction, mass percentage and everything. And then which is a temperature dependent. We know that molarity depends upon temperature. So molarity is a temperature dependent quantity. They may ask as an assertion, reason or objective. Then better method is molarity only because it is temperature independent. So that also will come. Then Henry's law. Don't forget about Henry's law. Henry's law definition and application. Damn sure application of Henry's law is coming in the exam. Maybe sometimes objective, maybe assertion, reason. Don't forget to study the Henry's law and application. Then Raoult's law definition and example, ideal solution, non-ideal solution. You know there are 2 types of non-ideal solution. Solution showing positive deviation, negative deviation. This is very important. That is coming for theory 2 marks portion, sometimes objective, sometimes 2 marks. It's an important area. Non-ideal solution, positive and negative deviation from Raoult's law. These are all very important. Then next important one is azeotropic mixture. Azeotropic mixture is really important here. Azeotropic mixture, they may ask which is minimum boiling azeotrope, what is maximum boiling azeotrope and everything. Azeotropic mixture is very important. Then we can say colligative property. You know colligative property, there are so many colligative property. Elevation in boiling point, depression in freezing point, you know, lowering of vapor pressure, relative lowering of vapor pressure and osmotic pressure. Definitely they are going to ask numerical from this area. So before doing colligative property numerical, you must know how to put Van Hoff factor. You have to apply Van Hoff factor in the equation I. Even if it is 1, you should practice with the Van Hoff factor I, then do the numerical. Okay, so definitely there is a 3 marks numerical can come from colligative property, 100% sure. Okay, and colligative property, you know, whenever we are doing osmotic pressure, just study osmosis, just study what is isotonic solution, hypertonic solution, hypotonic solution and everything. Okay, osmosis definition they can ask. So what happened when red blood cell kept in the water, or what happened when red blood cell kept in salt solution? These all type of questions can come, sometimes objective, sometimes descriptive, everything. Okay, so then why osmotic pressure method is a better method? This is a most time repeated question. I can say very important question. Osmotic pressure method is a better method. Why? They may ask. Okay, this is very important. Okay, they will ask this. Why osmotic pressure method is a better method for, you know, measuring molar mass of macromolecules and everything. That's very important. Then very important area, other one. So they may give a solute 0.1 molar KCl, 0.1 molar NaCl, 0.1 molar CaCl2, 0.1 molar you can say urea, and they may ask which of the following solution has high boiling point, which of the following solution has high vapor pressure. We taught in the class how it is related, how boiling point related to Van Hoff factor, how freezing point related to Van Hoff factor. We studied already. So just this is very important area. And then last year most of the board paper, this numerical came. Abnormal molar mass, related association, dissociation, Van Hoff factor based numerical came. So association, percentage of association, what is degree of association, how to calculate. There is a formula of degree of association. We study like that, I minus 1 by 1 by n minus 1. We study that formula, that you have to go through it. Similarly, degree of dissociation, I minus 1 by n minus 1. We did that question. Just go through it. This can come for 3 marks numerical. These are the important areas of solution. You have to go through it. Okay, so we are moving to the next chapter now. Okay, all of you can hear me, right? Yes, are you here? Yes, listen. Now we are moving to the next one. See, so electrochemistry, which are the important areas of electrochemistry we are discussing. Okay, number 1, galvanic cell. They may ask, they may give some data, electrode potentials. 2 electrode potentials will be given. They may ask you to represent the galvanic cell. Which are the cell reactions? You have to remember sign of cathode and anode. We studied already. And flow of direction of current, flow of direction of electron. And what happened E cell when external potential applied is greater than, what happened to EMF of the cell when external potential is applied greater than E0 cell. We already studied electrochemical cell behaves as electrolytic cell when we are applying an external potential greater than E0 cell value. The galvanic cell behave as electrochemical cell behave as electrolytic cell. That we study. That is very important area. They may ask questions. And which is responsible for conduction of electricity through solution. We know that ions are responsible for conduction of electricity through solution. That is very, very important. Go through it. Okay. Then electrode potential. Definitely they may ask application of electrode potential. This all will come in objective question. The electrochemistry chapter has 9 marks. The weightage of electrochemistry chapter is really, really important, students. It's the most important chapter in this particular reader. So the weightage is high weightage. So much weightage is here. So don't leave any portion from here. So reactivity of metal using reduction potential value. We studied already. The reduction potential values depends upon the reactivity of metal, how it related to reactivity of metal, that you have to remember. They may ask arranging increasing order of reactivity, arranging decreasing order of reactivity. So which is a better coating for a particular metal to prevent corrosion. That type of questions will come based on electrode potential value. We discussed in the class, that area you have to remember. So how to predict which is a better coating for a particular metal for preventing corrosion. So for example, for iron, which is a better coating, zinc or you can say copper, which is a better coating. So the better coating, zinc or tin, which is a better coating. So always we know that the more reactive metal is a better coating for preventing corrosion. So the more reactive metal will act as anode, other one will behave as cathode. We discussed in the class. That area they will ask, they will give the reduction potential value, and they will ask which is a better coating for preventing corrosion and everything. Okay, so reducing property and oxidizing property they will ask. See, they will give the reduction potential value, and they will ask which is the better reducing agent, and they will ask which is better oxidizing agent. Definitely they will ask. So the reducing property and oxidizing property of metal they will ask. This all you can expect normally in objective type questions. Then next one is Nernst equation. That's the most important area in this chapter. Don't forget to study Nernst equation. So whenever you are studying, you have to study. There are 2 Nernst equation. Nernst equation for electrode you have to remember. Nernst equation for cell you have to remember. Mostly they are asking Nernst equation for cell. But sometimes they may ask Nernst equation from electrode also. It came occasionally. So remember, so Nernst equation from cell representation you have to study. Nernst equation from total cell reaction. How to write Nernst equation you have to study. The numericals. These numericals are coming 100% for 3 marks. The Nernst equation questions are really, really important. So just go through that area. Okay. Yes. Later we will upload this file into the link. You can download this all. So now just listen, you make sure that whether you completed this portion, whether you went through this portion, you have to remember, you have to check. Okay, so the next page we are talking. Yes, the next page is equal to terms related to electrolytic conduction. So that is that area, you know, that conductivity, resistivity, and everything. Numerical finding, resistivity, conductivity, molar conductivity, that is easy part. You already studied in physics, similar type. So we have so many equations that you have to remember. Okay, so variation of conductivity upon dilution. There are two things. Number one is conductivity. Number two is molar conductivity. So you should know variation of conductivity with the dilution. We know that conductivity decreases with the dilution. Conductivity decreases with the dilution. Conductivity decreases with the dilution. But molar conductivity increases upon dilution. Molar conductivity increases upon dilution. There are two different criteria here. So you have to study that thing properly. They may ask assertion reason question based on it. What's the variation of conductivity upon dilution? And what's the variation of molar conductivity upon dilution? They may ask the variation for a weak electrolyte, variation for a strong electrolyte. You studied a graph like this. We studied a graph like this. The straight line was strong electrolyte and the curve was, what, tell me, weak electrolyte. We were plotting a graph of lambda m versus root c, and this graph is really important. They may ask for theory part. So variation of molar conductivity upon dilution, that you have to go and study. Then Kohlrausch's law definition, very rare, but still you can't neglect that. We can't say which is going to come. So Kohlrausch's law also, you just go through it. Numerical based on Kohlrausch's law, that also you have to go through. That's an easy part. Just don't forget to study Kohlrausch's law. That's very important. Okay, now this is an area most of the students are finding hard. Products of electrolysis. So last year, last year they asked one objective question from products of electrolysis. So different set, there was objective question based on products of electrolysis. So you can expect like that, which will be the product obtained at the anode during the electrolysis of molten NaCl. What's the product obtained at the cathode during the electrolysis of silver-nitrate solution? What's the product obtained during or what's the reaction happening at the anode during the electrolysis of concentrated sulfuric acid solution? These all things you have to remember. So these all things, molten NaCl, dilute NaCl, silver nitrate solution, and dilute sulfuric acid, concentrated sulfuric acid. Just study the products obtained at anode and cathode. If you are not able to write in the form of equation, at least you study the product. In case if it is objective question, it is easy to get that. So don't forget to study. Sometimes they may ask. Then Faraday's law, there are Faraday's first law, Faraday's second law, numericals based on Faraday's law. This year we are expecting this. Okay, Faraday's law we are expecting this year, because last year they didn't ask any question from Faraday's law. So this year we are expecting one law. Definitely Faraday's law numerical is very important. Go and study. Okay, now commercial cells. Most of the students are leaving this commercial cell part. See, there are so many commercial cells, but you target these two. Don't forget to study fuel cell reactions and fuel cell advantage. Advantage, fuel cell reactions at anode and cathode. Advantages of fuel cell. Don't forget to study. It's an important area. Similarly, lead storage cell. You have to study the reactions. If you are finding this one very hard, commercial cells, if you are finding very hard, at least you study the fuel cell reactions at anode and cathode, total reaction, and advantages of fuel cell over other commercial cells. Number two, lead storage cell. Lead storage cell, what are the reactions happening in lead storage cell? What is the reaction happening during working? What is the reaction happening during recharging? That all you have to remember. So these are the area in electrochemistry. So electrochemistry is a big chapter. Weightage is 9 marks. So concentrate. See, numerical part is mentioned here and theory part is also mentioned. Later we will put pin. You can download this. Okay, so we are moving to the next page. Yes, listen. So we are moving to the next page now. Okay, see now. Kinetics, chemical kinetics we are talking. So what is rate of formation? So kinetics is an easy chapter. Weightage of kinetics is 7 marks. 7 marks for the board exam. Okay, so weightage of chemical kinetics is 7 marks. So which are the area you have to concentrate? Rate of formation, rate of disappearance, rate of reaction. There is a small numerical can come. Sometimes it may be an objective question. question will be given in the form of a numerical, and objective question will be there. What is rate of formation? What is rate of disappearance? What is rate of reaction? You study like that, how we already explained in the class what is the rate of formation and rate of reaction, how it is related. They may ask one question in sample paper, it is there. We already submitted so many questions. Just practice such questions, that is going to come. So rate of formation, rate of disappearance and everything. Factors affecting rate of reaction. That's easy question, direct question. I don't think it will come, but it is coming. It came in board exam before, so many factors are there. There are 6 to 7 factors affecting the rate of reaction. It can come for 2 marks. If the question is so easy, you can expect this one. So just go through it. Okay. Difference between order and molecularity. That's very important area. That's a permanent question, order and molecularity. If they are not asking, they may ask you to find out order. They may ask you to find out molecularity of a reaction. Simple questions are coming. See students, board exam contain little harder questions, moderate questions, simple questions also. These are the simple questions they can ask from this area, order, molecularity and everything. So numerical based on rate law equation. We studied like that, how to write a rate law equation, how to write numerical, at the table based numerical we did in the class, that you have to go through it. Numerical based on rate law equation, how to make equation, what happened to rate of reaction when concentration of A is doubled, what happened to rate of reaction when concentration of A and B is doubled. Like such questions are coming, that is coming. And moreover, table based numericals are also coming under this category. So numericals based on rate law equation you have to study. Then numerical finding order and rate, that is based on table based questions. So just remember, this is one of the important areas, pseudo order reaction. You can expect an objective question from pseudo order reaction. Previously they were asking what is pseudo order reaction, give an example. Now we can expect objective question based on pseudo order reaction, how it is, what is which of the following, what is pseudo order. We study like that. In pseudo order reaction, one of the reactant is present in large amount. So they may ask, if one of the reactant is present in large amount, what will be the order of the reaction. So when one of the reactant is present in large amount, that will be disappearing from the rate law equation. So that is that type of reactions we studied. Pseudo order reaction, there are pseudo first order reaction like that. So just go and study that area. That's very important, very important. Then they may give 2 reactions, and one reaction they may give slow and other one they may give fast, and which is a rate determining step. We know that slow step is rate determining step. And one more important thing, molecularity of the slow step is equal to order of the complex reaction. We know a complex reaction takes place in 2 steps, and which is the slow step, that is equal to rate determining step, and the molecularity of the slow step is equal to order of the complex reaction. That you have to remember, and that they can ask. Okay, rate determining step and everything. Sometimes they may give two steps, and they may give the mechanism of the reaction. They may ask which is a rate determining step. So easy, the slow step is a rate determining step. Go and study that area, very important. Then graph related to integrated equation, prediction of order, slope and everything. We explained in the class when they will be giving a graph, and based on the graph, they may ask what is the order of the reaction. We told you one shortcut in the class. Do you remember how to identify order of a graph from a order of a reaction from a graph? Very shortcut, very simple shortcut. We can say if log term is not there in y-axis, log term is not there, order is 0. If log term is there in y-axis, order equal to what? Tell me, first order. 0 and first order are there in the syllabus. Just go and study that. Then integrated rate equation numerical, very important, 100%. Integrated rate law equation based numerical. There are 0 order equation, there are first order equation. Whenever you are reading the numerical, you have to check which order is given. Most of the students are making this mistake. They may give 0 order, and you will apply first order integrated rate equation. They may give first order, you will apply 0 order integrated rate equation. So remember, read the question properly, which order is given. Accordingly, you have to apply the equation, right? So if order is given first order, go and apply first order integrated rate equation. If order is given 0, go and apply 0 order integrated rate equation. Sometimes for radioactive disintegration series, they may not give the order. So remember, radioactive disintegration series follow first order, right? Radioactive disintegration series follow first order. So remember, this is the now numerical based on gaseous reactions. We know that AB gas giving A gas plus B gas, that type of equations. They are measuring the amount in terms of pressure, partial pressure. So there is a separate formula for it. We are deriving that equation, and for the general equation AB gas giving A gas plus B gas, we have a formula. Just study that formula and apply. Sometimes they may ask gaseous reaction numerical. Last year it came. Last year this one came. This one came. So very, very important area. You can't avoid this. In kinetics, you can't avoid these two topics, right? Very, very important. Then dependence of rate of reaction on temperature. Rate of reaction, that's an easy topic. Rate of reaction directly proportional to temperature. With every 10-degree rise in temperature, rate become almost double. That you can explain with the help of Arrhenius equation. So Arrhenius equation is showing a rate of reaction and temperature relationship. Just go and study that area. Then numerical based on Arrhenius equation. Arrhenius equation, there are three different forms. We know that one is equal to normal form. What is given in the reader? K equal to A into E raised to minus EA by RT. Another one is logarithmic form. We are converting it to logarithmic form. Another one is, after getting to logarithmic form, we are getting another equation. Third equation, log K2 by K1 is equal to EA by 2.03 R into T2 minus T1 divided by T1 T2. That you have to study that equation also. They may ask numerical based on Arrhenius equation. Go and study. It's a direct numerical will come. Don't worry. Just go and study. Collision theory, very rare. Sometimes an objective question can come, collision theory. What's the condition for collision? What are the conditions? Sometimes they may ask, even though the reactant molecule has activation energy, their collision, they will not react. Why? Because of lack of proper orientation. Collision theory told proper orientation is also required for effective collision. For taking part in the reaction, proper orientation is also required. So collision theory is also they can ask. Remember this all. This is the important area in kinetics. Okay, weightage of kinetics is 7 marks for the board exam. Remember 7 marks, 3 marks sure from this whole area. 3 marks sure. 2 marks from the order and molecularity and this all pseudo order. Just go and study this area. It's an easy chapter. Don't forget to study, right? The next one we are talking. All of you can hear me? Yes. So we are talking now further. Okay, listen now. Next one we are talking coordination compounds. Going to tell you about coordination compounds. Coordination compounds, yesterday we did revision. Coordination compounds, which are the important things in coordination compounds. Make sure that you study this all. Some terms related to coordination compounds they will ask. They will ask ampidendate ligand. What is definition of ampidendate ligand? You have to go and study. There are so many ampidendate ligand, CN minus, NC minus, SCN minus, NCS minus. So many ampidendate ligand we studied. So NO2 minus, ONO minus, study that definition. You have to write properly. Sometimes they may ask objective question, which of the following is an ampidendate ligand. They may ask which of the following is a chelating ligand. We know that chelating ligand is bidendate or polydendate ligands are considered to be chelating ligands. They can form ring-like structure complex. So remember this chelating ligand. Then what is homoleptic complex? You have to remember what is homoleptic complex. If complex has similar type ligands, so same ligands, that is homoleptic. If complex has different ligands, that is heteroleptic. They may ask. Then coordination and ionization sphere. So you have to remember that which is coordination sphere, which is ionization sphere, like that. Now, structure of EDTA, go and study. Number of donor atom in EDTA, 6. Number of donor atom in EDTA you have to study. Method to find out coordination number of a complex, we studied in the class. They will ask simple question. Last year one question came. What's the coordination number of COEN thrice? COEN thrice 3 plus. This question came last year. So number of donor atom in EN is 2. So coordination number equal to 3 into 2. Remember 6. This is a method. So method to find out coordination number, you have to make sure that you know how to find out oxidase state as well as coordination number. So coordination number, you know how to find out. Oxidase state, we are substituting the charge of each and every ligand and finding the oxidase state, that you have to remember. Then IUPAC, 100% they may ask IUPAC. Sometimes they may ask IUPAC name of ionization isomer of this complex. So IUPAC anyway, one question 100% sure from IUPAC. Then method to write the formula using IUPAC name. They will give IUPAC name. You should select the formula, which one is the correct formula of this complex. So that also you have to remember. Reverse IUPAC name will be given. You have to find out the structure. They may give structure. They may ask IUPAC like the Werner's theory. Werner's theory, postulates of Werner's theory, I don't think it is coming directly. But application of Werner's theory is like that. How to predict this? 100% sure question, students. 100% sure question. Every time they are asking method to predict formula of complex by number of ions generated or precipitated obtained with a reaction with AgNO3, reaction with AgCl, like that. See, that area you have to study. You know, if cobalt is the central metal ion, definitely the coordination number equal to 6. You have to keep 6 ligands inside the box. If 2 AgCl precipitated, means you have to keep 2 chlorine outside the box. If 1 mole of AgCl precipitate, means you have to keep 1 chlorine outside the box, provided 6 ligands must be there inside the box if metal ion is cobalt, like that. So we already explained in the class. That area is very important. They are going to ask. Okay, then prediction of hybridization. Prediction of hybridization. Normally, they are not going to ask explain the hybridization. Never. They may give a complex and they will ask what is the type of hybridization here. You can predict. There are short method we told in the class. Within a fraction of a second you will get hybridization. We told the method in the class. So strong ligand, what is the hybridization? Weak ligand, octahedral complex, weak ligand, what's the hybridization? Strong ligand, what's the hybridization? You studied already. That you have to remember. Strong ligand, what's the hybridization? Weak ligand, what's the hybridization? What is the exception? We told you Cr3 plus there is an exception. Nickel 2 plus there is an exception. We told you one short method over here. Very easy way to predict hybridization. And magnetic nature. A magnetic nature and shape. You know, coordination number is 6. Shape is octahedral. Coordination number 4. Shape is tetrahedral. We know that. Study that. Okay. Then we are moving to do further. This area is very important. The prediction of hybridization and magnetic property is very important. That is coming next. Crystal field theory, which area they will ask. Prediction of magnetic property of crystal field theory. Sometimes see students one short method. I'll tell you. We studied already the how to predict magnetic property of complexes. There are 2 methods. One method is using VB theory and the method is using CFT, crystal field theory. If they are asking what's a magnetic nature, they are not asking explanation. Better go for VB theory, better go for CFT prediction. We studied CFT prediction. What is the order of filling of electron when delta O greater than pairing energy? What is the order of filling of electron when delta O less than pairing energy? That all will come here. So just study that prediction of magnetic property. That's very important. Then calculation of magnetic moment using the formula. There is a formula, reason for color of the complex. Then the color depends upon the nature of the ligand. That all we can say. Stability of complex. We know that chelating ligands are highly stable. Chelating ligands are highly stable than normal ligands. Stronger ligands are more stable. If you have a chelating ligand and stronger ligand, go for chelating ligand. Okay, if you have normal stronger ligand and chelating stronger ligand, so go for chelating ligand. So chelating ligands complexes are highly stable. Remember, so the stability of the complex, they are asking objective question. From here, you can expect objective question, 1 mark question like that. This is explanation very rarely asking, but they may ask questions from this why carbonyl monoxide complexes are highly stable. Sometimes they may ask explain the bonding in metal carbonyls and others. Go and study, don't leave it. It's an important area. Then prediction of isomerism. We know there are so many isomerism. Structural isomerism, stereo isomerism, ionization isomerism, how to predict these all. That all you have to remember. Prediction of optical and geometrical isomerism, we have different formula we studied in the class. Which are all complex will show geometrical isomerism, which are all complex will show optical isomerism we studied. Linkage and ionization isomerism, very important. They may ask which is the ionization isomer of one complex. Yesterday we had this session before. So remember, so linkage and ionization isomerism is very important. A complex will be given, do prediction type of isomerism and IUPAC name of ionization isomer, everything they will ask. IUPAC name of ionization isomer, everything they may ask. So remember that. Okay, just study that. The next one we are talking next chapter. Okay. Next chapter, D and F block elements. D and F block elements, as you know, this is very easy chapter. So give reason questions are mainly important. You have to go through this. So transition elements show variable oxidation state. Why? Scandium show +3 only. Zinc show +2 only. Manganese show maximum number of oxides. These are the repeated questions in the board. Higher oxidation state of metal is observed with oxides and fluorides. Why they will ask? Transition methods are paramagnetic. Why? They will ask these all points as give reason. Just go through these points. I will upload this one in the link. You can download it. It will be there. Okay. So this is the thing. Zinc has low melting point, low enthalpy of atomization. Electrode potential of copper is positive. Why? Electrode potential of zinc is negative. Why? Why this one is negative and why this is positive? We already told the shorter method in the class. Just apply the rules and deliver. These are the things. Okay. So Cr2 plus or Fe2 plus, most time repeated question, Cr2 plus or Fe2 plus, which is the better oxidizing agent. We know that Cr2 plus is a better oxidizing agent. It undergo oxidation to form Cr3 plus, which has stable D3 configuration. We studied, so just go and study these all portions. Okay, then lanthanoids and actinoids, that's very important. Lanthanoids condition for reason for color of complex, explain why transition elements are behaving as good catalysts. Just study this. This is direct question. Just go through it. Okay. So actinoids and lanthanoids, actinoid contraction from element to element is greater than lanthanoid contraction. Why? They will ask why D6 is more stable in stronger ligand, like that. These questions are very important. Just go through it. Okay. The preparation. This is an area. This potassium permanganate and potassium dichromate. The D block element has weightage of 7 marks. Out of 7 marks, probably 1 or 2 marks will come from this area. 1 or 2 marks will come from preparation of potassium dichromate, chemical properties of potassium dichromate, preparation of potassium permanganate, properties of potassium permanganate. 1 or 2 question will come. Okay, this is a method, right? So this is very, very important. Remember that. So we are moving to the next chapter now. Halogens. Already I told you these all in the class. Halogens, how it is coming, preparation of halogen, MKR, AMKR, how to predict number of monohalogenated product, which isomer can form, how many monohalogenated product, that you have to remember. Finkelstein reaction, Schwarz reaction, Sandmeyer's reaction, diazotization. Actually, organic chemistry you can study in a different way also. Name reactions will come. Method to distinguish test will come. Method to distinguish test is coming. Name reactions are coming. Then mechanisms are coming, conversions are coming, then you can or order of acidity of acids are coming, phenols are coming, order of basicity of basicity of amines are coming. This is the area you have to remember. Repeating it again, I'm just consolidating organic in a faster way, because organic, it is written here, you can go and study this all. I'm just consolidating organic, how you have to study in the last moment. Okay. Organic, you have to check whether you studied all method to distinguish test. Method to distinguish test. Method to distinguish test. Okay. So method to distinguish test you have to remember. Method to distinguish test. This is coming. Method to distinguish test. Number 2 is like that. You have to study name reactions. Name reactions. All name reactions. Okay. All name reactions. Number 3 is equal to you have to study order of boiling points of different compounds, organic compounds. Then you have to study order of nucleophilic addition reaction, order of nucleophilic addition reaction of aldehydes and ketones, order of nucleophilic addition reaction of aldehydes and ketones, aldehydes and ketones. Aldehydes and ketones, that's very important. Order of nucleophilic addition reactions of aldehydes and ketones. Then we have to study order of acidity of phenol, order of acidity of phenol, carboxylic acid, aldehyde, everything you have to study. That's very, very important. Then you have to study the next one is, you can say, yes, order of basicity of amines, order of basicity of amines, order of basicity of amines, that's coming. Order of basicity of amines is very, very important, this whole area. So then you have to study IUPAC. Normally 1 mark will come IUPAC. Mechanisms will come. Mechanisms will come. You can say mechanisms will come. Mechanisms will come. These are the highlighted area in organic chemistry. If you are studying this way, by selecting and give reason questions. Give reason questions, we supplied a separate worksheet for you. Give reasons separately. Give reasons can come. Give reasons can come. Give reasons. And identifying ABCD type questions, word problems, and conversions. These are the area normally organic chemistry is asking. So each and everything you can study like that. Make sure that you study this whole area. Means whenever you are going and studying method to distinguish test, we have a separate file we already sent in the class. So how to distinguish test, which is a test to distinguish between different compounds. So just study each and everything. Method to distinguish test between, primary, secondary, tertiary alcohol. Method to distinguish test between, primary, secondary, tertiary amine. Method to distinguish test between aldehyde from other organic compound. Method to distinguish test using iodoform test. Ketone from other organic compound. Methyl ketone from other organic compound. Alcohol, certain alcohols from other organic compound. So these all things are coming all together, these all portions, if you are selecting and doing revising now, these portions, if you are doing properly, organic chemistry has a weightage of total, 7 marks from carboxylic acid, 6 marks from amines, 6 marks from halogen, 6 marks from alcohols. Altogether, weightage is equal to 25 marks. If you are studying these portions alone, for example, IUPAC, so many are there, 1 mark. Method to distinguish, you may get 2 marks, probably 2 marks, can come more than that. Okay, name reaction, you may get 3 to 4 marks because name reaction, direct name reaction can come. Sometimes complete the reaction can come from name reaction. What's the product? Like that they can ask. 3 to 4 marks you will get. Order of boiling point, or 100% one question sure order of boiling point. Physical property, which has dipole moment more, which has less dipole moment, which has more dipole moment, which has high boiling point. That type of question, 1 mark sure. Order of nucleophilic addition, 1 mark sure. 1 mark, 1 mark, 4 marks. So method to distinguish 2 marks. IUPAC 1 mark, sure topic. Then order of acidity. Yes, 100% students, order of acidity, Ka, acidity, Ka value, pKa value, how it is related as acidity. Order of acidity you will get 1 mark sure. Order of basic nature, 1 question will come sure. Mechanisms, nowadays, they are not mostly mechanisms, they are not asking you to write mechanism, but sometimes objective questions can come from mechanism. You can expect 1 to 2 marks. Sometimes if it is objective, you can say it can come for 1 mark. Sometimes mechanism directly, if they are coming, it will come for 2 marks. Mechanisms are written in this chart, you can go through it. Okay, this is there. And another one, identifying give reason. Give reason questions you will get 5 marks sure. Give reason, we already sent a give reason paper today. It is there, updated give reasons. Questions are there in the group. You can go and check. It is there, 5 marks is coming. Okay, 5 marks give reason, sure. This give reason nowadays give reason exactly will not come like that. Give reason based concept will come for assertion, reason and everything. So you can expect 5 marks from give reason. Identifying ABCD questions, you can expect 5 marks from ABCD type questions. And conversions you can expect 3 marks. Conversion can come 3 marks. So these are the weightage normally in organic chemistry. So each and everything is written here. I will send that link here. You can download later. This is equal to organic chemistry. These are the important organic chemistry. Now see, in halogen compounds, other than this mechanisms, means mechanism I told you, mechanism you may get more than 2 marks because it may include SN1, SN2. So many questions are there. So you can extend this number by including SN1 and SN2 altogether. Mechanisms you will get around 1 to 3 marks sure. Okay, 1 to 3 mark question from mechanism alone you can expect, including SN1 and SN2. SN1 and SN2 is coming under mechanism part. So remember, so these are the areas in organic chemistry. So don't forget to study this area. Make sure that you are doing this area, right? Then we are moving to the halogen part is there. It is given here. Name reactions are given. Give reason questions are given. A very important give reason questions are charted here. Don't forget to study at least this topic because so many are there. Study this topic. Okay. For example, order of boiling point of different halogen compound. That is their order of boiling point is there. We already studied order of boiling point. Order of boiling point, what happened to boiling point upon branching? Which halide has high boiling point, like that. So questions are coming, and which is more reactive towards SN1, which is more reactive towards SN2. That all coming under mechanism part. Yes, mechanism part. Remember this all. So this all comes in the exam. Okay, then we are moving to do further. Okay, listen. Yes, what is next? Okay. So these are the this is equal to alcohol, phenols. The mechanisms are given. These are coming under give reason question. Bond angle of either greater than tetrahedral bond angle. This portion, don't forget to study. This is very important. Bond angle related give reasons. These are all coming under give reasons. Assertion reason question can come. Bond angle in either is greater than tetrahedral bond angle. CO bond length in phenol is less than alcohol. COH bond angle in alcohol is less than tetrahedral bond angle. So these all questions are coming. Okay, these are the name reactions. These are the prediction of major product. A, B, C, D type question can come. So remember this one, chemical test to distinguish alcohol and ether, method to distinguish primary, secondary, tertiary alcohol. So all organic part we already told in this all, just go through it. Okay, that is another one. Okay. Any other doubt you can ask? These are the organic chemistry portions. So we already told, just go through this file. Okay, these are the ethers. Now we are moving to do the next chapter, aldehydes and ketones. Aldehydes and ketones, we know the name reactions are there. Important name reactions are given here. Remember this: Stephen, Ittard, Gatterman, Koch, side chain chlorination, aldol, Cannizzaro is written here. Nucleophilic addition, order of reactivity, addition of ammonia derivative, iodoform test, chemical test to distinguish between, based on these are the compounds, based on iodoform test you can distinguish pendant 2 on, pendant 3 on, ethanol, propanol, acetophenone, benzophenone, like that. Tolerance reagent test, how to test to distinguish between ethanol and propanol. Ethanol is aldehyde, aldehyde will give tolerance reagent test. Remember conversion based on aldol condensation, we studied Cannizzaro reaction. Remember the most important area in aldehyde ketone chapter is aldol condensation, Cannizzaro reaction, related conversions and everything. Tolerance reagent, iodoform test. Iodoform test 100% sure. 100% sure iodoform test questions are coming. 100% sure aldehydes and aldol condensation is coming. Aldol or Cannizzaro, one question sure. Out of this aldol and Cannizzaro, one question sure, students. Okay, remember that. That's about this. Okay. Next one, we are talking about carboxylic acid. Carboxylic acid preparations, HVZ reaction, decarboxylation, acidity of carboxylic acid, prediction of order of acidity, then why benzoic acid does not undergo Friedel-Crafts reaction. Just study this portion, is very important. This is required for quick revision. Okay. Then this is amines. Amines, just we are talking IUPAC is there, chemical properties are there. These are the things already we studied. Order of basic nature, Hofmann's bromamide reaction, why aniline is giving metanhydro aniline upon nitration, why aniline cannot undergo Friedel-Crafts reaction. These all very important topics are here. Just go through it. Okay, these are the area we already sent in the group. You have to go through it. These are the topics given in the group. Okay. Yes. Anything else? If you want, you can ask me. I'm available here. So order of boiling points, order of solubility of primary, secondary, tertiary amines, aniline insoluble in water. Just study this order. So these are the important areas. So we complete it. Okay. So all the best. We want maximum commitment. Don't waste single minute. Now hope it will be a very good exam for you. We are confident that it will be an easy exam for you. All the best then. Bye. Anything else? Okay, students.